Good morning, my children. This is video 1. May take more than one to get this all done. It goes with the pink packet that hopefully you've been given by now. And maybe you're watching these individually, or maybe you're projecting them up onto the TV so everybody can watch it once. I don't really care how you do it, as long as we do it. So this is 10.1, the mole, a measurement of matter. We're relating Avogadro's number to a mole of a substance, calculating the mass of a mole of any substance, describing methods for measuring the amount of something, and comparing and contrasting atomic mass of an element and its molar mass. So the vocabulary, we need moles, or abbreviated MOL, Avogadro's number, which is a nice number, representative particle, that could be, it could be an atom, or an ion, or a molecule, just anything that could be represented as a particle, and then molar mass. And then we've got some key equations, and notice they are very similar. They both use 6.02 times 10 to the 23rd. It's just one is in the denominator and one is in the numerator, and that depends on whether we're trying to calculate moles or representative particles. So here we go. Completion section. This will probably be the end of the first video when we do these 5 blanks, because I want to keep them short so I can put them on Google Classroom and not have to make YouTube. Not that I mind YouTubes, it's just a little bit easier this way. So we're going to complete with orange and to check our knowledge. So chemists relate units of counting of mass and of volume to a single quantity called the mole. The number of representative particles in a mole of a substance is 6.02 times 10 to the 23rd. To find the mass of a mole of a compound, scientists add together the atomic masses of the atoms making up the compound. When you substitute the unit grams in for AMUs, atomic mass units, you obtain the molar mass of the compound. There are 6.02 times 10 to the 23rd representative particles in a mole of any substance. Again, representative particles, that could be atoms, ions, molecules, formula units, electrons, whatever. That many of them is a mole. Okay, so there's the front side. Let's flip over. Of course, yours is pink, mine's white. And let's see, the true false. Do we want to do the true false? There's sometimes true, always true, and never true. Let's try them. A mole of a pure substance contains 6.02 times 10 to the 23rd atoms. Sometimes that's true. When's it not true? If it's molecules, if it's photons, right? If it's apples, right? It doesn't have to be atoms. It has to be 6.02 times 10 to the 23rd, but it doesn't have to be atoms. So that's sometimes true. Number 7, the representative particle of a compound is the molecule. That's sometimes true. If it's a molecular compound, if it's an ionic compound, then those are called formula units. So it's not always molecules. Sometimes it's formula units. So it's sometimes true. A mole, number 8 says, of CCl4 is composed of 1 atom of carbon and 4 atoms of chlorine. Well, that's never true. I know what you're thinking. It's CCl4, isn't it? 1 and 4, but it's not per mole. If it said a molecule of CCl4 is 1 atom of carbon and 4 atoms of chlorine, then that would be always true. But since they're asking about a mole, it would be 1 mole of carbon and 4 moles of chlorine atoms, but that's not what they asked. So we have to say never true on that one. Number 9, a mole of carbon atoms has a mass approximately 3 times as great as the mass of a mole of helium atoms. Well, carbon is 12.01 grams per mole, or AMUs. And helium is like 4.04, I think, which is about 3 times. 3 times 4 is 12. So, yeah, that's usually true. I hope it's always true. And then the molar mass of nitrogen is gas is 14.0 grams. Now, at first blush again, that looks like that should be true. But if it's molar mass, if it's molar mass, that would be grams per mole. Then it would be true. Oh, wait, that's not even the only reason it's not true. Nitrogen gas is N2, right? Because nitrogen is diatomic. So it would be 28 grams per mole. So no, that's never true. No matter which way no matter for which reason we decide, that's not true. All right, so matching Avogadro's number, that is that 6.02, right, times 10 to the 23rd. And molar mass is the mass of 1 mole of something. And mole then is the SI unit that measures the amount. That's key later on. And represent particles, then that is the atoms, molecules, or ions present. Okay. So now we're to problems. There are 4 of them. How many moles is 9.3 times 10 to the 15th atoms? What is the molar mass of ethane? Find the mass of 3.65 times 10 to the minus 2 moles of K2SO4. And how many represented particles are in 2.5 moles of peroxide? That's hydrogen peroxide there. So we need on number 15, we've got 9.3 times 10 to the 15th atoms of Pb. We're going to take that and we're going to use Avogadro's number. And remember, we want atoms in the denominator. We want moles in the numerator. So we need to look back here, right? We're looking for moles, so it's this one. So we're going to take 1 mole over 6.02 times 10 to the 23rd. And get an answer, see what you get there. Number 16, molar mass of ethane. That's easy. You can do that. No problems. No problem at all. So go ahead and work that one out. Find the mass of 3.65 times 10 to the minus 2 moles of K2SO4. I think we're going to need the molar mass first, which you know how to do, of K2SO4. By the way, K2SO4, potassium sulfate, right, K2SO4. But we're finding the mass. So once you get the molar mass, you've got the moles, right? You've got the moles here, and you're going to multiply that by the molar mass, which is in grams per mole. So the moles will cancel. So you're ready to go on that one. And then how many represented particles are in 2.5 moles of H2O2? Well, we got moles, we want particles. Again, moles to particles, we're going to do 1 mole over. Wait. That's not... Are we looking for moles? No, we've got moles. We want to know particles. So we're doing this one this time. We're doing this one this time. So we got the number of moles. We want to multiply by 6.02 times 10 to the 23rd in order to get the answer there. So do those. Have those ready to submit later on. If you want to go ahead and work on the other 3 pages and then turn in these problems after you get through all the videos, then do the problems. That will be fine with me. So this is the end of video 1.